in
Yes.
15 minutes. Are you ready?
Yes, I'm ready.
Okay, let's go.
Yes. Thank you. So can you able to see my screen?
Yes.
Okay. Okay. Yeah, we are good to start, right? Hello.
Yeah, that's good.
Yeah. So hello everyone. Like myself, Vijay sir. Today I'm here to present my capstone project. The title of my project is like Clear Trade. So like the main goal of this project is to make AI based stock recommendations more transparent and understandable for user. Like we see that there is a stock market where every user cannot understand like what is going behind it and what is the logic behind that. What we see on the website is like bars and graphs. So to make it more understandable for user and to make it transparent for a investor, so I made this web application in understandable and transparent way. So we'll go to the agenda. So today will quickly walk through the agenda of this session. So we'll be discussing the motivation and problem statement, why it is important, what is the gaps we have, and like we'll be discussing the background related work, synthesis matrix, feature list, and what is the gaps, and like how I design the system, and finally what are the results I have observed. We'll be discussing few of the things in this session now. So like motivation. So if we look at like financial markets data today, there is huge amount of data like stock prices, company reports, and like news. So this is like among humongous data which will be evolving around the financial data. So investors usually look at multiple sources before making decisions. But doing all this analysis manually is like difficult and time consuming for an investor. So that's why AI is being used. But but there is still a problem which I'll explain in the going forwards slides. So we'll be now going to problem statement. So the main issue is that like most, like I would not say there are AI models available in the, they are not available in the market. There are available in the market as well now. So the main issue is that like most AI models today only focus on prediction accuracy. They act like black box, which is like they give the output, but they don't give like what is the reason behind, what is the logic running behind. They'll be not showing clear transparency to user. So also there are different types of data like technical indicators, company fundamentals, and news sentiments are often used separately. Because of this, investors don't trust the system fully since they can't understand the reason. As I said, like it acts as a black box, it does not show what is the reason behind these decisions. So we'll be discussing the background to understand the problem better. There are like basically these stock market and investors major look on like three factors, and the stock market runs behind majorly on three key factors. The first one is technical analysis. Technical analysis majorly it use indicators like relative strength index and moving averages of the company. It's like short term trend, like how is the stock going per day, per 15, per a week, per 10 days. It works on like short time period like week, 10 days. So next major key indicator is like fundamental analysis. It is like looking at the company's performance like earnings and performance ratio, growth of the company, what are the projects there. It majorly fundament analysis deals with long-term plan of the company, like reading complete profile about the company. The third one is like sentiment analysis, like it understands market mood through the news. Like we can see like how global news and like it impacts the stock market. So, but existing systems does not combine all these three properly with explainability, and that's the gap my project addresses now. Related work in there are few previous researchers have been going around these topics. In previous researches, different machine learning models like LSTM and random forest have been used for stock prediction. Some works focus only on like financial data, other focus on like sentiment, other focus on fundamental. Like my project explainable AI has also been introduced, but still a fully integrated and explainability system is missing in like in previous researchers. So this is a synthesis matrix. Like this slide summarize like what existing systems do and what they are lacking, and like what is my approach uh, have been to overcome those previous problems. It clearly shows that like that no system combines multiple data sources along with explainability in a unified way. So like as we can see, the first research paper, it majorly works on only on a technical analysis, just one factor, and the second research paper it majorly works with a fundament analysis. It majorly focus on like one of the other key factor. So as we can see, like there are different research papers going on, but they focus on individual. So the gap is what this is the gap which motivated me to design this app. Like so we can try integrate all these three key factors and make a unified web application to solve this problem. So this is these are the few features I have built for like current and future scope. In current system, like I have built a solution that combines machine learning prediction models, fundamental validation, and sentiment analysis. So and I have integrated an AI agent. All these signals are and produce a recommendation with confidence score. So for future enhancements, like there are like I have planned to add real time data like real-time trading data and portfolio optimization and like better explainability tools with deep learning models. Like these are the like few current features, and future enhancements have been bifurcated and I have been implemented in my application and project now. So we'll look into the workflow, how I've been doing this. This slide explains how system works from a high level perspective. Like let's start with it starts when a user select a stock. Like and the first step, user you're going to select a user stock ticker. Then the system collects different types of data like historical price data and company fundamentals and news what is happening around that company. So after that, it processes the data by calculating indicators such as moving averages, like and relative strength index of the company. Like there are few other multi factors. Then machine learning models analysis these features to predict trends. And finally an AI agent combines all the signals and generates a unified like buy or hold or sell recommendation along with an explainable explanation. So that's how the system workflow I have designed. Next, like approach, the how I approach to solve this problem. The approach I followed is mainly a design and implementation based. I have collected financial data sets, processed them, and trained machine learning models. Then I have added sentiment analysis from news. All these outputs are combined using an agent based system, and explainable AI techniques are applied to make the results understandable and in easy way. So this is like solution architecture. This slide shows how the system is structured at high level. The front end is like I have built the front end using React, which handles user interaction. The back end I have developed using Django, which process requests and manages data. The system is divided, as I said, like it majorly works on three major indicators. So the major core component, the system is divided into three main analytical models: technical analysis, fundamental analysis, and sentiment analysis. Each model processes a specific type of data and generate its own output. Eventually, each individual model will give different outputs. These outputs are then sent to AI agent, which acts as a decision layer. Like then the AI agent comes into picture and it validates and it acts as a decision layer, combining all these three outputs, and the agent combines all these signals and generates a final recommendation along with explanation. This is how the solution architecture of this website or web application is being developed. Now the agent architecture. So the agent takes inputs from technical modules, fundamental modules, and sentimental modules. So each of these gives a different signals about the stock. Then the agent combines these signals using weighted logic. Like as said, like technical module plays a major role. So it takes
I,
a
I just want to remind you that you have 5 minutes left.
Yes, yes. Thank you, thank you. So as I said, like technical indicator plays a major vital role. So it gives like 50% of weightage, and followed by fundamentals analysis, it takes 30% of the weightage, and as such sentiment, it takes 30%. So overall, it comes at 100%, making a decision, under complete decision. Based on this, it calculates a final score and generates buy, hold, sale recommendation. It also provides explanation for the decision. So implementation. So this slides explains what I have implemented during the project. I have developed, as I said, I have developed front end using React and built backend APIs using Django, and I have collected and cleaned data, including stock prices, financial data sets, news. And then I have implemented like taking the raw data, and I have computed data into indicators like relative strength index and volatility. I have trained multiple machine learning models such as logistic regression, random forest, and like I have the few prediction and machine learning models. I have implemented sentiment analysis using natural language protocols techniques. Finally, I have built an AI agent logic that combines all outputs and generates buy, hold, or sell recommendation with explanation. So this slides focus on actual development, coding, and execution of the system. So data analysis. For analysis, I have used stock data from 2022 to till now. It's not like recent, but like not exactly real time data, but I've used like most recent data sets. I have calculated returns and volatility and technical indicators. I also compared how different sectors behave in terms of like market patterns. Findings. The results shows that stock markets are not normally distributed. They are heavy tail. Like volatility tends to cluster, meaning high volatility periods are followed by more volatility. So technical indicators helps in short term predictions. Like technical indicator plays a vital role in a short term prediction, while fundamental indicators are used for a long term stability, and like who are looking for a long term stock profits or like long term step, it will find fundamental analysis plays a major role for that one. And sentiment analysis plays an important role, especially during uncertain market conditions, like how geographical global news can impact stock market. It impacts that one. So to conclude, I have developed clear trade, a explainable AI stock for a system for stock recommendations. So it integrates technical, fundamental, and sentiment analysis into single frame, and and the key distribution is that it's not only predicts but it also explains the decision, which improves trust and usability. As I said, like transparency and the trust,
You have 1 minute left.
yes, which is lagging in like current stock market. So that's all from my end. Like if you have any questions, we can. If not, we'll be going through the demo part. Shall we continue with the demo?
Yes, you have 5 minutes.
Yes, thank you. Let me check. Give me a second. Yes. Can you people able to see my screen?
Yeah,
So this is how my website, I mean, web application UI looks. So this is I mean, simple UI have built using React. So this is a clear how UI looks. It is a dashboard and history. And as we can see here, user can enter a ticker of any stock market like
sorry. I can only see join your team's meeting screen.
uh,
I think you're sharing different screen.
different. Oh, sorry, my bad. Can you see able to see
Yeah,
now
yeah,
at least?
yeah, yeah.
Yeah. So this is how like UI looks. I have built a simple and approach. I mean, very neat UI for a user. I have not complicated in like doing redesign. So I've used to build using React. So this is how it simple looks. So this is a clear trade, the logo of my application, and you can see there are three factors. Like in the first section, user can enter the taker of the any stock market. Uh, and as he selects analysis, then it shows like what is the logic behind, and as I said, like what are the key factors making, and it gives a confidence score so that he can make a recommend it. We only give recommendation. So let's check with like as it says like let's check Google. So it analysis. So it like first let me explain how it works. So as a unified output, it gives hold percentage of 99. So it's saying us to not to buy or not to sell the stock. So it says like if you are having stock of Google, just hold, don't sell or don't buy. So it is giving some outputs like fundamental analysis, like what is the profit and earning ratio of the company, and what is the earning growth of the company, and what is the revenue growth of the company. And like as I said, like technical indicators play a major role. So this is how it says like what is the moving average of 10 days, what is the moving average of 30 days, and what is the overall profits of the company, and what is the volatility of the company. And like it gives like news of Google recent news, which is like 10 headlines. So how it impacted for validating this decision. And it says it gives a unified decision over here. As it says, the system suggests of holding the stock rather than buying and selling aggressively. The confidence it gives an explainable manner. And we have integrated the graph for the last 90 sessions, and how it shows the how the market is been going for this Google stock for last 90 days. And we have an in AI chat as well for questions of like how if the user is having any questions, like let's check what is the sentiment like for any specific terminology or for specific factor. If you want to check, then it is used. Like if we select like sentiment, it says like sentiment as score does not impact as of now anything. So let's check with relative strength index. So it says like how it is impacted for this unified decision. And we can select like how is fundament analysis is been, I mean, helpful for this unified decision. So as like we can select for any other ticker as well, for showing like it works for any other as well. If you people have any random ticker in your mind, you can just say me so we can type, or else I'm gonna type any other one.
You have 1 minute left.
Okay, let's check. As you said, no people. Less as it's we can check Tesla.
Why don't you try BLDR? Sorry,
PLDR.
yeah, BLDR.
PLDR.
It's just a random one.
Just random. Builder first source. It says it is there and it shows how it is being impacted and how it is. Yeah, how it says to sell if we are having any stock of this company. It says like to sell, and it says like their company are a growth rate, earning growth is not so good and revenue growth is not so good, and it says how it is been dipping over 90
Yeah, I
days
got it. I
period.
was just looking at the signal that you gave. What about TSLA?
Tesla, okay, just give me a minute. TSLA. Yeah, it says to hold as of now, like
Okay.
there, and like how what are the recent news which is being impacted for this thing. It is showing like what are the recent news and what are the technical factors of the company and how it is being growing or dipping down for the last 90 sessions, and as an unified decision, it gives like to hold the stocks. If we are having stocks of this company, it says to hold as of now for as 100%.
So at what point will it become a buy? When it becomes greater than 100%?
Yes, like take it to buy.
There's got to be three possible signals:
Yes,
sell,
yes,
hold, or buy.
yes,
When will you buy it? When it becomes greater than 100%? What is that
yes.
100% there?
I mean, hold percent. It says like hold. You if sometimes the user may not like 100% believe this hold is like it's if the company's unified decisions given by AI agent is like it is divided from 0 to 100%. If it says 100%, it means unifiedly we have to hold. Like if it says like hold 50%, sometimes user may think like okay he might hold or he may not. Like so if it says like 100%, it's unified like fixed 100% to hold off the decision. We should not
No,
like.
no, I got it. So basically,
Hmm,
the 100% is based on a composite confidence score among all three different
yes.
technical, fundamental, and sentimental sentiment. All three of them are
Yes.
indicating the same thing as this in that it should be held. Is that what it means?
Yes.
Thank you.
All right. Thank you so much for your presentation. Now let's
Okay.
go to the next person.
Thank you, Vidyasagar.
Thank you.
Hi, Chen.
Hi.
Are you ready
Let,
for your presentation?
yeah, let me share my screen. Um, yeah. Can you see my screen?
Yeah.
Okay.
Okay. You have 15 minutes.
Okay, thank you. Hi, everybody. I'm very excited to share my capstone today. My project is enhancing medical named entity recognition retrieval with large language model and contrastive learning. This is a two-stage system to achieve translate the clinic text to a formal and more professional language. Here's the agenda. I will from the motivation and go through all the problem statement, background related work, and then I will compare what I have now and what in the future, and also to show my data collection and analysis. And then will be the result and conclusion and limitation futures work something. And let's start from the motivation. Nowadays, we will have the very high non-standardization of clinic experience, and this is like the picture showed left. And then we have a semantic text from the traditional machining algorithms, and this is also a problem. Like when we talk about common code, maybe it's we cannot figure it out. It's upper representation or infection or not. It's just a common code. And then it's a transition from the literature. It's a clinical difference, clinical difference distinguishing to constructive learning. And also the real time, we don't have a really powerful real-time retrieval challenges from the large-scale terminal goals. And also the last one is it's like a branch of graphs. We don't know which one is we really want, and this is the motivation part. And then is the problem statement. Like I mentioned, the fundamental conflict in medical large language module is not that strong.
Chen, sorry, I want to interrupt you because you have to put it on presentation mode. I think you're on a different slide. What we're seeing is just the title slide.
Sorry?
I'm just seeing that slide number 1. You're not on slide number 1, are you?
Yeah, I'm already in the problem statement.
We're only seeing the title slide here. You're not sharing the right one then. We are only seeing slide number 1.
Let me share. Let me try again.
And put it on full, presentation mode, please. Sorry for the interruption.
I'm sorry. I didn't share correctly. So, could you see the problem statement now?
Can you put it on presentation mode, please? Thank you.
Yeah. So now we are in problem statement, right?
Yeah, we are, but it's not in presentation mode.
I'm where I show is presentation module now.
Never mind. Continue with this. Sorry, didn't mean to interrupt. Continue, please. Sorry.
Okay, sorry for the sharing. And for the problem statement part, the first thing what I mentioned is the medical large language module. And the next one is we have the problem with the data set because the privacy regulations, we don't have big enough data set and high quality to use for our module training. And the next problem is when we have the data set, we need to hide the personal information. And when we do this, sometimes we lose some information. And the next part is the limitation of static NER architectures. That means even we got a data set, it's maybe sometimes it's a particularly field of medical part. It cannot cover all the medical languages. So this is another problem. And also with the privacy regulation, and also it's hard to deal with the data. So the module of the medical field is not performance really well. And also the last thing is we need to build a really nice system to deal with this. Now I move to the background. The background is there's a lot of people have done with the related work about my part. The NER is a gateway. Named entity recognition is the gateway about the.
I think your slide is not on the background slide. Yes.
If I out of the present its background.
Yeah, continue.
Yeah, now it's background, right?
Yeah.
Okay. Okay, I will show like this. Sorry. For the background part, let me see, I have finished first one, and the next one is the revolution of the old module to large language module. That make a possibility for us to deal with a large data set for training the module. And the next one is the challenge about the privacy part. And the next two are challenge about the privacy part. Many papers have already mentioned this. And the next one is retrieval augmented semantic spaces. That is the study about the normalization part, which is also the constructive part, learning part. And also the last part is the NER as a representation and retrieval task. This is a background about this project. And for the related work, I want to highlight three most important part. Is the extraction part is I use as a stage 1. It's a ByteBERT module ByteBERT. And the next one is normalization part. I use a SpanBERT module for training this part. And the last one is the retrieval. That makes us to make it very quick, like we can achieve the real world project of this system. And we can pay attention, like all these three are very new. They are all after 2020. For this part, the feature part, I want to highlight the very first two one. The model is 2 stage. The first stage is target 1. We need to figure out and we need to find from the large data set about the clinic text. We need to find what we need. And the next part is retrieval part. The retrieval part, we use the SpanBERT module to train. And the next part I want to highlight is entity market retrieval. We use the entity market retrieval like we have a very sharp knife to cut which part is what we really need. And for the future feature, I want to figure out the first one and the last one. What my project now is a 2 stage, but I think it's in the future we can figure it out like end-to-end generation link. So it don't use because the 2 stage can influence each other. But if we can find some idea to end-to-end, it's kind of like one step. And the last the last one is a privacy strategy. I think maybe someday we can have a more large data set can fix this problem. For the synthesis table, my approach is 2 stage, what I mentioned already, and the entity marker is also mentioned in last slides. And also the limitation part is I think we need to balance the data set and balance our system performance. Now let's have a look about the whole picture of the solution architecture implementation. And the stage 1 is span detection. For this part, we need to target we need to scan the clinic text to figure out which part is what we need or we really need, and train the model to get familiar with this part. And the stage 2 is the normalization part. In the stage 2, we compare the clinic text with what we already have, the formal and the standard language. This is the whole picture about the 2-stage system. And then we deal with the project from the very beginning, which is data collection. We have a long way to go in the data collection because the medical data is not that easy to collect. And at the first beginning, we try to find some data from the Kaggle, but that data set is not big enough. And then I turned to the NCBI. I found a data part more than 7,000 something. And then I separated it into 5,000 for training and almost 1,000 for test. With the data analysis part, the first thing is a medical corpus as the foundation. That means we use the NCBI as a big data set. And then is a double E, like entity mark to find what we are looking for. And then it's a hard navigation, negative learning that forces the module to learn distinctions about all the data set. And the next two, I think we want to make the system is believable. So we want to every conversation contrastive result can have a evidence based. And the last thing is, even I got more than 7,000 data set. It's a big one for this. It's big enough for training this model, but I still give up almost 1,000 because I think the quality is more important. Let's move to the result and the findings. Before that, I want to figure out 3 matrices for the medical NER system. The first is precision. That is like measure if we can find the, we can tag the clinic test very correct. And then is recall. Recall is we need to measure if we can cover all the information we need. This is a very important part, especially in the medical area, because we don't want to miss any diseases for the patient. And the last one is F1 score. The F1 score is a balance for the precision and the recall, because we don't want to just have the recall or precision. We need to balance this. This is a measure about the performance of this system. I need to show this like. Then this is the stage 1. In the left side, I separate the 7,000 data set as 3 parts. I use more than 5,000 for training and almost 1,000 for the test part. And during the 5 episodes, we can see from here like the training loss is continue decrease, and also the F1 score is continue increase. And the result is in the right side. We can see the precision part is more than 83%, and the recall is almost 90%, and the F1 score is 86%. That means our system, at least in stage 1, performance really good. This is
We
stage
have
2.
3 minutes left.
Yeah, thank you. And for the stage 2, we have the spam burnt module to training this part. And for this part, I think we use the result from the stage 1, which is performance really good. And when we got the pieces from the clinic text, we compare with what we have already, which is from the data set, the 5,000 data set. And this is the result. The right side is the result of the stage 2. It's also performance really good. So for the conclusion, all the two-stage system is very robust, and also we have a high fidelity bind to drive span tagging. This is we can see from the result. Its performance, the performance is really good. And then the second the second stage is spine burnt contrastive normalization. The result is performance is really good too. And also the production grade fencing optimized retrieval that can make the possibility that this system can use in the real life, because the infection is really fast. And like I also already mentioned, we want to everything have evidence-based insights. And the last part is all this performance shows this system can use in the real life. But also we have some limitations. And the first thing, I think the two-stage is have 2 problems. One is it needs more time, and the other one is it will influence each other. Like if we got the first stage result good enough, we will have chance to get a good result from after stage 2. But if we miss stage 1, the stage 2 cannot give us good performance. And the second one is it still have a big gap between the formal and clinical text. I think maybe we need to put more attention about the data set to fix.
Time is up. Let's go
okay.
with the demo.
Okay.
You have 5 minutes.
Mm-hmm. Oh. Can you see my screen?
Yeah, let's go.
Okay. So this system is a NER contrastive retrieval system. This is a two-stage system. The first part, we need to input the clinic text and first step, and then we will go through the stage 1, the named entity recognition, and also the stage, and then is the stage 2 is the normalization part. Let's see a demo. When we have it, we need to analyze it. And then we can see it highlight some diseases. This is the stage 1. It can recognize all the diseases we have from the clinic text. And we can see from here, when we got the original one, it will normalized with more. This is particularly exactly the same because this is already not a informal language, informal text. Yeah, let's see another one. Yeah, we can see here. We've list the top 5 most related to our dataset after we normalized the result. Yeah, for this one, the original one is more like oral English or daily words. And then it's normalized to very professional, like we will never use it until we search for it. And let's see another demo. Then we clean it. Yeah, after we analyze it, its the first stage is recognition. We got 3 pieces of this. And let's see. Yeah, the original is substernal chest pain, and after the normalization, it will be a angina pectoris. And also, this is the original one, and after the normalization, it's like more professional medical language.
Hey, I have a question, Chen. Can we put in a prompt that I give? Can you type it in? I want to see how that comes out. If
Yeah.
that's okay. So my prompt is patient presence with.
You want me to print it in, right?
Yeah, can you type it? Would you have the time if you have the time? I just want to see how that works.
Okay.
Patient, T-I-E-N-T. P-A-T-I-E-N-T, yeah. Presence, P-R-E-S-E-N-T-S.
Present.
Yeah.
Word.
With, W-I-T-H, with. Acute, A-C-U-T-E. Hypertension, H-Y-P-E-R. H-Y-P-E-R. T-E-N-S-I-O-N. And headache. Next sentence, full stop, period, next sentence. Prescribed, P-R-E-S, C-R-I-B-E-D. Lisinopril, L-I-S-I-N-O-P-R-I-L.
T-R-I-O.
P as in Peter, R-I-L. Yeah, just analyze this. I want to see how that, it should also, if it does a good job, it should also fix the spelling mistakes. Let's see. This is good because hypertension and headache are considered to be symptoms or diseases.
It's recognized. Yeah, it's recognized these two diseases.
Great. Does it recognize the medication? I think that's a good test here. The lisinopril medication, does it recognize it?
Okay, thank you.
In this case, wait a minute. Acute hypertension is matched to hypertension.
Hypertension? Okay.
No, page down.
Yeah,
so
here.
Acute hypertension has been normalized to hypertension, which is good. And then what else did it do? Headache was the original,
Headache.
and then it normalized it to headache.
Headache is just a headache. It's
only two of these were normalized then. Okay, thank you.
Thank you.
Okay,
questions
if
for me?
no one's have any question, it's for today. Thank everyone for presenting.
Yeah, nice job, Vidya, Sagar, and Chen. Appreciate the time.
Thank you, Professor.
Bye.
Thank you, Professor. Bye, guys.
Thank you. Thank you all.
So we can leave now, right?
Yeah.
And
Thank
if
you.
we don't want to go to other sections, we can leave like just leave, right?
Yeah, I think so. Yes.
Yeah, thank you so much.
Thank you.
Thank you.
Thank
Thank
you.
you, Toph. Thank you
Bye.
for hosting the session.
Thank you.